Hello, dear colleagues. It's time to start the work of our section, Cybersecurity and Internet of Everything. This is the great possibility to provide the information, results of the research, and some ideas and discuss those ideas. I hope that we will be able to do it during the work of our today's conference and the work of our section. And actually, as it was told in the main section, it's proposed to follow the current schedule, and everyone has a schedule. And based on this schedule, we will try to be close to the required time. So I kindly ask to try to fit and maintain reporting up to 10 minutes, no longer, and according to the requirements of the providing the questions, it's better to reduce the time to 7 minutes and 3 minutes for the discussion and questions. But if you require a bit more time, it's possible to use this time. So it's pleasure to open the work of our section, and I think that it's not necessary to ask all the participants and guests of our section about the presentness now. And while we are working and following one report to another report, we can actually start from the first report and ask our authors and the guests to prepare the questions for the reporters and address those questions after the end of the presentation. So the first report, according to our schedule, is the localization of scene simulation in smart warehouses applications based on UWB technology.
Yes, can I share my screen?
Yes, please.
Good morning, everyone. Okay. Do you see my presentation?
Yes, everything.
Are you hear me?
Yes.
Okay. Good morning. My name is Olga Pogudina, and today I present our research work, because now I'm PhD student of Politecnico di Bari, Italy, and our topic is localization of things, simulation in smart warehouse application based on ultra-wideband technology. To understand what a smart warehouse is, it is necessary to start at the beginning talking about Industry 4 as a reference. Industry 4 are based on the Internet of Things, digital communication capabilities, and robotics. Internet of Things describes devices with sensor processing ability, software, and other technologies that connect and exchange data with other devices and system over communication network. In IoT, localization of things is the process of locating, tracking, and navigation any possible collaborative or non-collaborative nodes. In our case, we are talking about warehouse where both people and UGV operate. People can be equipped with decks, while UGV are equipped with anchors. UGV can move at a high speed. Therefore, even if the presence of various types of obstacles, it is necessary to locate people to avoid collisions. Of course, there are various localization technologies that use different type of signals now present of this slide. One of the common types of signal for obstacle localization is the path of UGV. Is leader. However, the limitation of leader is that if a person suddenly appears from behind an obstacle, and the methods of this leader may detect this man too late. Moreover, leader is not very cost effective. As we can see, ultra-wideband signals provide high occurrence and scalable solution. So the ultra-wideband technology has a low cost and high accuracy. And this slide, according to the requirements for smart warehouse, we need a solution with a low latency in the localization of moving object, and we conducted the review of ultra-wideband methods, taking into account errors that occurs during object localization. Most of this work focuses on accuracy, but consider only a small number of tasks. Without the scalability, without the method of large number of objects. Therefore, in this work, a simulation model was developed to account for scalability. It is represented as a bipartite graph, where the nodes must exchange a predetermined number of signals to obtain information about the tag's position. We assume that if the signal is received and no conflict from signal collision in the air occurs, the object coordinates are calculated correctly. Based on the simulation results, we obtained the graph showing the dependency of localization quality. As we can see, quality is unsatisfactory given the specified delay in coordinate updates. For example, for 14 tag and 4 anchors, we haven't any good results of localization. Therefore, methods for improving localization quality were considered, including the use of internal position measurements such as data from internal sensors like accelerometer, gyroscope, and other. A simulation model was developed in Omnet++ framework. And this model, taking into account movements of object UGV and also people who works in warehouse, obstacles which present in different type of obstacles, including the bottles with aqua, because it also happens, and signal exchange. In the future research, this model will be used to obtain localization quality result based on various measurements, because the measurements may be not only internode, intranode, but also it is possible to use two different internode measurements. For example, combination of Wi-Fi for 5G, it is possible, and ultra-wideband. Additionally, different models for combining data from internal and external sensors were examined to enhance the accuracy of object localization. You can see, for example, time table, which we can took to the account IMU precision, IMU localization, and ultra-wideband update of data. And for these goals, we can use Kalman filters is widely used to combine different data of source. And data fusion algorithm helps to integrate multiple sources of measurements using statistical or probabilistic model. So the scientific novelty of our work is systematic model for analyzing the scalability of the object localization task, which consideration of the application for ultra-wideband technology in indoor environments. This model incorporates various signal exchange protocol between anchors and tags, as well as in the integration of internal sensor data to determine the frequency of coordinate estimation. Thank you for your attention. If you have questions, I like to answer, or you can send me to this email. Do you have question?
Thank you for the providing such really meaning report and results of your research. And questions, please, Alexander.
Thank you, Olga, for your report. Can you please tell me how to estimate a minimal count of beacons for your localization method?
According to the latency, we need to send beacon from tag to all anchors around the object for, if you can see, half milliseconds. So every half milliseconds, every tag must send beacon. Are you...
You disrupted for a moment. I meant how many points of transfer and receiving signal we need for a certain square of our work. Understood?
No, you mean how many anchors needed to localize the object?
Yes, yes, yes.
It is for these goals we need it is a solution for movement UGV and movement object. If we have in distance, in near UGV, at least one man, we need to stop UGV. So it is enough one anchors which localize a short distance between UGV and man to stop UGV, to have to solve the problem with collisions in warehouse where people work with UGV.
And accuracy will be...
Yes, the problem is accuracy. It's not enough only distance, because the point of this object can be and any point in circle. But for goals warehouse, it is enough to stop UGV to solve the collision problem. But of course, if we need to a good accuracy, it's needed at least 3 points if we have two-dimensional space, and at least these points, these anchors must be in good position around the object. I understood this problem, but according to the goal of specified goal of this research, it is enough only one anchor, only one distance from one anchors. And according to the measurements, it can be time of arrival, or it is also can be measurements which present in the slides on TWR, TDOA, and another methods, which can be involved in ultra-wideband techniques.
Thank you for your answer. Thank you for your answer. I understood. So the minimal is 1, but better to use 3 or more.
Yeah. Yes.
Thank you for the providing the answer provided in the report, I think that we can move forward, and also it will be possible to continue the discussion maybe after the end of work of the section before the switching to the final section. Thank you again for your presentation. Well, we moving forward, and it's proposed to provide the next planet report with the following title: Using blockchain technology for monitoring projects during wartime and post-war transformation and recovery. We not hear.
Hello? Can you see my screen?
Yes.
Everything is okay, just a moment. Let me... So, good morning, distinguished colleagues and esteemed guests. I'm Alexander Skachkov, an associate professor of the Department of Project Management in Urban Economy and Construction, Alexey Beketov, National University of Urban Economy in Harkiv. I'm honored to have the opportunity to speak with you today about the research of the authors Yulia Guseva, Igor Chumachenko, Alexander Skachkov, Irina Kadykova, Natalia Datsenko, using blockchain technology for monitoring projects during wartime and post-wartime transformation and recovery. The implementation of projects during wartime and post-wartime periods in Ukraine is characterized by specific conditions and challenges that significantly affect the planning, execution, and monitoring of these projects. These challenges include security concerns, supply chain disruptions, limited access to resources, and workforce challenges caused by mobilization and migration. During wartime, the state shifts its prioritized towards defense and social assistance, which may impact the funding and implementation of other projects. Conversely,
I'm sorry for disruption. If you showing us a slideshow, we can't actually see it.
Now it's the first slide. Thank you for your attention, but it's only the first slide was shown. So, innovative solutions are required to mitigate the risk associated with wartime conditions and facilitate positive processes during post-war transformation and recovery. One such solution is blockchain technology, which is gaining its importance and popularity due to its unique transparency, data immutability, and security features. Blockchain can offer significant advantages for monitoring and managing projects, particularly in challenging environments where reliability, efficiency, and accountability are critical. This study explores blockchain technology potential to enhance project monitoring and management during wartime and post-wartime recovery in Ukraine. So, can you see the second slide?
Nope.
Sorry, so then I will show it this way. And now,
Yes.
if it's okay, oh, thank you. Since its inception, blockchain has primarily been associated with cryptocurrencies. However, today its applications are much broader. This technology has the potential fundamentally transform many fields, including project management. This trend is confirmed by an analysis of the publication activity of researchers publishing their findings in scientific journals that indexed in Scopus and Web of Science database. Starting from 2016, and we can see a rapid increase in the number of studies on blockchain, and let's pay attention that data are for the first half of current year, 2024. Only about 2% of these studies are related to project management and closely related areas, but the growth trend is also evident for this category of articles. So most of these studies relate to the field of engineering, computer science, business economics, construction building technology, telecommunication, environmental science ecology, energy fuels, operation research management science, and information science and library science. Interestingly, the most of the research is currently conducted by researchers from China. The analysis of 32 real implementation cases identified the areas of blockchain used in project management. The analysis showed that the application of blockchain technology in project management was used for various purposes across several industries. Most use cases focused on information management, with a few adopting blockchain for payments and contract management. Among the subcategories that you can see here, supply chain management was the most studied area, followed by progress, payments, lifecycle management, financial transactions, quality management, environmental sustainability, design, research management, security payment, and bidding. The identified use cases were analyzed according to the project management body of knowledge areas. Thus, communication management has included 80% of the publication, followed by stakeholder management, cost management, procurement, quality and schedule management. A smaller number of publications related to risk, research integration, and scope management. Based on analysis, the publication blockchain can be a useful tool in project monitoring process due to transparency, immutability, and decentralization properties. In particular, the following direction can be identified. The first, transparency and data immutability. Blockchain ensures transparency and immutability of records, allowing accurate documentation of all project data This helps ensure the reliability of the data used for project performance analysis. The second, change and version tracking. All project changes can be recorded in blockchain as transactions. This allows tracking of project changes that may affect the critical path and other project metrics. Third, smart contracts for process automation. Smart contracts can be used to automate certain processes in the project, such as automatic payments after completing specific tasks or phases. This can help minimize delays and ensure timely task execution. Fourth, decentralized management. Blockchain enables decentralized project data management, which is useful in large projects with many participants. And finally, risk tracking and management. With the help of transparency of blockchain, it's possible to track progress and identify potential risk of or delays that may affect the critical path. This helps may take timely actions to mitigate risks. So, using blockchain technology during project monitoring, it helps improve management accuracy, transparency, and efficiency, particularly in environments with multiple stakeholders. The implementation of blockchain technology for project monitoring analysis may consist of the following steps. The first, needs assessment and platform selection. It is necessary to determine which aspects require transparency and automation through blockchain, and select the blockchain platform that best suits these needs. For example, Ethereum or Hyperledger Fabric, Binance Smart Chain, and so on. Second, solution architecture development, smart contracts for automating business process, API interfaces for interaction with blockchain and other systems. Next, integration with existing system, then testing, deployment, user training and support, and finally monitoring and improvement. So here you can see figures that represent the block diagram of the respective process in ID zero notation context diagrams and first level decomposition. So the implementation of blockchain technology for project monitoring has the potential to become an important tool, especially during wartime and post-wartime conditions. The technology ensures data transparency and immutability, records change and versions, automates process through smart contracts, provides decentralized management, and allows for risk tracking. Blockchain contributes also to enhancing the security and reliability of information systems, which is critical in conditions of increased cyber attack threats. The implementation of blockchain technology for project monitoring includes several stages, such as needs assessment, platform selection, solution architecture development, integration with existing system, testing, deployment, user training, and support. The developed model of the respective process in ID of zero notation outlines the main stages of implementing blockchain technology in project management processes. So I hope this presentation on the topic using blockchain technology for monitoring project during wartime and post-wartime transformation and recovery was interesting. Thank you for your attention, and I look forward to hearing your feedback. Thank you.
Thank you again for the providing the results of your research. Let me to provide some brief question before we continue the work of our section. Please say, while you consider actually use a blockchain technology of existing or widely spread networks, you need to consider the changing price of the gas to execute the smart contracts, because with changing of the price for the cryptocurrency currently, the price of the gas to maintain the work of smart contracts may be too high, and maybe it's reasonable to consider some maybe parallel existing or maybe another synthetic blockchain technology to maintain it, to reduce the required actually price and to make it free of charge, because the maintaining of gas is not reasonable for all companies, and a lot of companies decided to avoid this approach in the direct form.
So the key challenges include to provide this technology include lack of technological infrastructure and high costs of implementation. And sometimes it can be a resistance to adopting new technologies. And of course, this gas prices also can be an obstacle to use this technology as well.
Thank you for your presentation, and we continue.
Thank you. Thank you.
You can stop the sharing of screen.
Thank you.
The next our report is the method for detecting and classification cyberbullying in text content using neural networks. Please, I'm reminded that it's necessary to feed the time requirements, so try to feed 10 minutes limit.
Okay. Can you see my screen?
Yes, everything's okay.
Okay, thank you.
Yes.
Good day, dear colleagues. I'm pleased to present to you the work dedicated to method for detecting and classifying cyberbullying in text content using neural networks. The problem of cyberbullying is relevant among young people as they actively interact in the digital environment. At the state level, draft laws and educational campaigns are being adopted to raise awareness. However, these measures are not enough, as most cases occur outside of school's hours. Therefore, programmatic solutions are needed to detect and prevent cyberbullying outside of school hours, which will contribute to the safety of young people and will meet the Sustainable Development Goals, in particular number 3, 4, 5, 10, and 16. Therefore, the purpose of the work is to provide a safe space for online communication and prevent cyberbullying, which is in line with Sustainable Development Goals. To do this, it's necessary to develop a method of detecting and classifying cyberbullying in text content using neural networks, as well as identify existing types of cyberbullying. This slide shows the scheme of the method. The first stage is the pre-processing of the text for analysis. The input data at this stage is a text sample for detecting cyberbullying. The input text sample is cleaned of necessary characters such as punctuation marks, emoticons, and extra spaces. The second stage is analysis of the text for the presence of cyberbullying using the trained neural network model. The model analyzes the text and determines whether it contains signs of cyberbullying and calculates the percentage of such manifestations. If this percentage exceeds 50%, the text for analysis is considered to contain signs of cyberbullying and is passed to the next stage for detecting types of cyberbullying. The third stage involves assigns the manifestation of different types of cyberbullying in the text. At this stage, a model trained on types of cyberbullying is used, which analyze the text for the presence of specific types of cyberbullying and calculated the percentage of each type detected in the text. As a result of this stage, the percentage of each type of cyberbullying in the text is obtained. The output of the method provides the total percentage of cyberbullying in the text, as well as detailed information about the percentage of each type of cyberbullying. As a data for training classifiers and studying the effectiveness of the cyberbullying detection method, the datasets cyberbullying tweets for binary classification and cyberbullying classification for multi-label classification were used. The dataset cyberbullying tweets records divided into two classes: message contains cyberbullying and message without cyberbullying. The classes in datasets are balanced at 50 to 50%. The dataset cyberbullying classification records are divided into 6 classes, which you see on the slide. As part of effectiveness research of the proposed method for detection cyberbullying, software was developed, which allows determining whether a text message contains cyberbullying and what cyberbullying types are present in the text sample. For binary text message classification, 2 machine learning models were trained with LSTM and RNN with LSTM layer, and 2 different approaches were implemented. The results of accuracy, precision recall, and F1 matrix are shown in the table. The obtained results of statistic metrics of binary classification using both approaches suppress the result in other studies. For multi-label classification of cyberbullying types, several machine learning and deep learning models were trained. As can be seen from the figure, 2 models obtained better macrometrics indicators, so we will consider micrometrics indication further. This slide shows the micrometrics performance of machine and deep learning models for multi-label classification of such type of cyberbullying as age and religious. This slide shows micrometrics indication for ethnicity and gender types of cyberbullying. To evaluate the model on different data combination, cross-validation was performed on random data samples from the data set. For deviation shows that the cross-validation results are very close to the performance of the obtained model, especially in terms of accuracy, which confirms the stability and reliability of the BERT model for the task of detecting and multi-label classification of cyberbullying in text messages. The purpose of the study was achieved by developing the method of detecting and classifying cyberbullying in text content using neural networks, achieved 94% accuracy rate, suppressing existing approaches. This method supports sustainable development goals and can be applied in social and educational platforms to enhance moderation and provides physical support. Thank you for your attention.
Thank you for your report. Dear colleagues, have you any questions to our reporter? No? That I have one small question to you. I want to understand which type of reaction we can use for source of cyberbullying. It's a mute, ban, maybe notification, some type of marking.
Maybe we block this message and don't show for another user in social platforms. Maybe we can send this message to moderate to the people who can decide cyberbullying this message contains or not.
Maybe it will be useful to make some levels of hardness of that cyberbullying, for example. That's but permanent blocking is can be too radical solution for people who just mistyped some words with using T9, for example.
Thank you. We have such plan in future works to provide this.
Okay, thank you for your report. You can
Thank you.
stop.
Thank you for the providing of results of your research and discussing it. And actually, we asking the next our speaker to start his presentation. Please, object position methods in augmented and virtual reality for mining system technologies combining. Please.
Greetings. Where am I? This question has been as fundamental to humanity as what is the meaning of life. Perhaps our entire fascination with stars and astronomy was just an attempt to find our place in this world. The ability to determine location made possible both the discovery of America and Magellan's journey. Today, localization remains a battlefield, where one side projectiles try to understand their location, while the other side technology attempts to make them lose their way. Imagine, we have a database created by brave men and women who explored hazardous zones, risking their lives. This database tells us everything about explosive ordnance in a specific sector, their type, angle, and exact coordinates. As engineers, we want to visualize this data in a user-friendly format so a regular citizen returning to their war-affected homeland can simply take out their phone, open an application, and use AR to find a safe path home. To solve this challenge, we need to understand what AR really is. It's just a contextless video stream, sensor data, and an overlay where we draw additional information. We have no direct way to display something at real-world coordinates. But if we can localize our device, determine its exact position and angle at the moment of frame creation, simple math can help us solve this problem. So let's examine available technologies. First of all, the Global Navigation Satellite System. And it seems perfect. Directly determine our position via satellites using a small module present in every phone. However, we immediately face seriously accuracy limitations. Even in the best case, with 5-meter accuracy, 32% of measurements will be outside this radius. That's unacceptable for critical tasks involving explosive ordnance. Precise point positioning technology attempts to improve GNSS accuracy by compensating errors. It requires a convergence period of 20 minutes to several hours to achieve decimeter level accuracy. However, if signal is lost, the system needs full reinitialization, starting the convergence process again. This limitation combined with still insufficient accuracy, makes it problematic for dangerous zone navigation. Real-time kinematic technology offers centimeter-level accuracy through a different approach. It uses a base station at a known location that monitors satellite signals and calculates corrections. These corrections are transmitted to mobile receivers in real time, allowing them to achieve centimeter accuracy. However, this requires specialized RTK models in user devices and a network of expensive base stations within 10 to 12 kilometers of the user. Mobile operators are implementing this infrastructure on safe territories, but relying on the RTK ties the project to either significant infrastructure investments or limited coverage areas. SLAM technology offers another approach, where exact global coordinates aren't necessary. It analyzes for video streams for feature points, corners, textures, contrast areas, and builds a 3D map relative to the initial position. However, it operates in local coordinate system, making it challenging to sync with global coordinate data. Photogrammetric mapping provides an interesting alternative. By processing overlap in aerial photographs, it creates highly detailed and accurate 3D models of terrain. Unlike real-time solutions, it can use powerful computing resources during preprocessing to achieve better accuracy. However, changes in terrain conditions like snow, puddles, and new craters can cause loss of feature points. Now, we've examined each technology, so let's look at their comparison. As we can see in this table, each method had its unique strengths and limitations. SLAM provides excellent local accuracy but can't handle global coordinates. GNSS works everywhere but lacks precision. P improves accuracy but requires long initialization. RTK offers the best precision but demands expensive infrastructure. And photogrammetry gives us a detailed model but faces challenges with environmental changes. But what if we could combine these approaches in a way that leverages their strengths while mitigating their weaknesses? Looking at our architecture diagram, we can see how different technologies could work together in 4 main stages. First of all, the digital surface model stage. Here, we create a foundation by capturing detailed terrain data through photogrammetric mapping, processing it into a point cloud, and building a comprehensive digital twin of the sector. Second, this digital twin enables a virtual environment where we can plan operation, train personnel, and conduct risk analysis, all before anyone steps into the dangerous area. Third, the explosive ordnance localization stage integrates this virtual model with real-world operations, enabling precise road planning and creating digital twins of detected objects. And AR layer adds an important layer of accessibility, allowing operators to literally see the invisible dangers and safe passes overlaid on their real environment. While significant challenges remain, like reliable synchronization between Vyacheslav Sergeyevich, excuse me, can you mute? Thank you. While significant challenges remain, like reliable synchronization between digital models and AR systems, handling areas with few visual features, and mobile device computation limitations, this direction seems promising for creating a system that could help people navigate hazardous zones safely. In conclusion, while integrating these technologies in a huge engineering challenge, the concept of a zone digital twin serving as a basic coordinate system looks promising. Future researchers should focus on developing sync algorithms between different sources, creating mechanisms for accuracy verification and drift detection, and handling dynamic environmental changes that affect feature points. Thank you for your attention.
Thank you for the report and questions, please. Please.
I have one question. So why you didn't look to 5G localization for 5G technologies in this case, in your problem? Because it's very actual.
First of all, as far as I know, 5G is 5G requires existing infrastructure, and it may be, problematic in dangerous zones. But maybe I'm wrong, and there are some possibilities to use it without infrastructure.
In case like existing techniques, I need to maybe it's needed to look for these techniques. But as I understood, in Ukrainian is real problem to involve these techniques, and we can discuss after because maybe I can give you some.
Okay, thank you for your approach. I will definitely research the topic of 5G. Maybe it would improve the system. Thank you.
Thank you again. And are there any questions? Well, in this case, Pablo, please stop sharing of your screen. Thank you again for your report.
You're welcome.
And we're moving forward. The next presentation is pipeline processing during importing large files into web-based systems.
Hello everyone. Can you see the screen?
Yes.
Yes.
Can you
Please.
Good day, everyone. My name is Andrei Litvinov,
Can you
and
hear it?
I'm here on behalf of my colleagues Alexander Godunov and Alena Chepelevich from the National Aerospace University, Kharkiv Aviation Institute. And today we're excited to present our research on pipeline processing during importing large files into web systems. So let's begin. On these slides, you can see the contents of our presentation, and I will not waste any time here, so I will give word to Alena.
Thank you so much. Let's start with the problem we aim to solve. In web applications, importing large files, for example, things of formats like CSV, XLSX, or XML, often results in critical issues. For instance, server response timeouts or memory limitations can prevent these files from being processed effectively. This creates significant barriers, especially when handling tens of or even hundreds of thousands of records. Our objective was to address these challenges by designing a pipeline architecture tailored to the needs of large file imports. This method not only streamlines the process, but ensures compatibility and scalability across web systems. Our objective was to design a processing method capable of efficiently importing large files into web applications while overcoming typical limitations. This required not only managing large datasets, but ensuring compatibility with existing web systems and scalability for future growth.
So let's talk about our goals and tasks. The aim of our work is to streamline large files imports into web applications, and to achieve this, we focused on identifying and evaluating tools and libraries that process large files in chunks, ensuring memory-efficient operations. Also, we include exploring methods for splitting data into manageable portions for step-by-step processing, designing scalable solutions, including data quiz and modular pipelines suitable for distributed and microservice systems. And the last thing that we focus on is creating a practical implementation to demonstrate the effectiveness of our proposed approach using a PHP backend and MySQL database. We have two main issues that we can define. First is the memory limitation. Larger files than server capacity can crash the process, and the execution time while importing large datasets often exceeds acceptable time limits. For example, many popular CMC platforms attempt to upload files in a single pass, which isn't available for large files.
So we analyzed several PHP libraries. libxml, which efficiently processes XML data in small chunks, and DOM.xml and SimpleXML, which require loading entire files into memory, making them unsuitable for large datasets. Batch processing methods emerged as the clean solution, allowing data to be processed incrementally. Through our analysis, we proposed 3 architectural approaches. First one is single pass processing for small files. Second is batch processing using a data queue, our preferred approach, and you will see why. And the third one is REST API integration for specialized use cases.
So let's see on our architectures. The first architecture processes the entire file in one step, storing it directly into database. It have advantages of simple and fast for small files, but fails with large files due to memory and timeout limitations. It is commonly used in CMC platforms, but unsuitable for handling large datasets. In the third architecture, data is uploaded and processed via REST API, often in batches. It has the advantage of ideal integration with external systems like Amazon or Google Merchant Center, but limited by API constraints such as data size per request and requires custom implementation for each use case. This is a versatile solution, but less general purpose than batch processing with data queue. And our favorite, the second architecture, breaks the process into manageable stages. First is files are read in batches. Second, data queue stores these batches for incremental processing. Then data is validated and stored in the database in steps. The advantages of this is that handling large files efficiently supports parallelism and isolates error in batches. And the cons of this are more complex to implement due to additional components like data queue. This was our primary choice, offering the best balance between scalability and functionality. Among these, the batch processing pipeline architecture stood out as the most effective.
Now let's dive into the component architecture of the proposed pipeline data processor, a critical element of our solution. So when a file is uploaded, the file upload module assigns tasks for processing each batch. The data parser module reads these tasks, extracts the relevant data, and queues it for further processing. And finally, we have a data processing module that retrieves batches from the queue, validates the data, and stores it in the target database. This architecture is modular, efficient, scalable, ensures data integrity, and of course supports large data imports while preventing memory overload and ensuring seamless task management. We implemented this architecture using PHP for server-side processing, MySQL for data storage, cron jobs for scheduling batch operations, and JSON queues for universal compatibility with different formats. The modular design allowed us to separate concerns, enabling independent updates or scaling for each component.
Here you can see the component architecture for data processors that we created. And the result of our implementation demonstrates the strengths of this approach. The pipeline efficiently handles larger files, processes data incrementally, and supports distributed or SAAC-based architectures. Beyond the technical benefits, this architecture also lays the groundwork for future research, such as integrating advanced data matching protocols or deploying this system in the cloud environments for greater scalability.
In conclusion, pipeline processing addresses the critical issues of importing large files into web systems. Its modular design ensures scalability and platform independence. Looking ahead, we plan to focus on developing data matching protocols and exploring distributed implementations in cloud environments. Thank you for your attention, and we are happy to answer any questions you may have.
Thank you, Andriy. And questions, please. Well, I think that it will be possible to continue discussion maybe after the end of work of our section, and it's also will be possible to address the questions maybe with some topic to our speakers, because there will be another report. But now we continue with the next report. Actually, implementation of the optimized data selection algorithms for web application. Daria, please.
Yeah. Okay, can you see my screen?
Yes.
Yes, everything okay, please.
So, good morning, everyone. Today, I'll present the solution to a significant problem many web applications face: the implementation of optimized data selection algorithm for a web application. We have discussed the challenges in filtering large dataset, explore a proposed solution, and share the results of our practical testing. Web applications like online catalog or e-commerce stores often struggle with the slow page loading times due to inefficient data filtering algorithm. Imagine searching for a product in an online store. User won't result instantly. However, as the product data increase, performance drops significantly. The goal of our work is to optimize those systems by reducing database load, improving page speed, and enhancing the overall user experience. Faster loading times not only keep users engaged, but also improve conversation rates, making it a critical challenge for businesses to solve. Now, to better understand the problem, let's dive into a typical use case. Filtering is a common feature in a web application, especially in an online catalogs with thousands of products. Users select retailer like brand, screen size, or RAM and expect relevant results instantly. However, traditional systems struggle to scale as the dataset grows. This results in slower responses, poor user satisfaction, and even higher server costs. Key challenges in filtering, we can see two of them. It's database bottleneck and user experience issue. As for the database bottleneck, every time user apply filters, the system needs to query the database multiple times. This creates a heavy load on the database, especially for a large dataset with 1,000 filters. For the user experience issue, those delays result in a poor navigation flow, where users are stuck waiting for pages to load. For businesses, this leads to reduced engagement and lower conversation rate. Additionally, filters often have between 100 to 215 options on average. If you evaluate the number of possible pages with 3, 5, or even 10 selected filters, the combination can quickly escalate into millions, as you can see on the table 2. This adds further complexity as the system must calculate not only which products meet the criteria, but also predict whether editing another option will yield and result at all. We analyzed 3 possible solutions to tackle this problem. Solution number 1 is to query the database for every filter option. This traditional approach is simple but creates a high database load and inefficient for a large dataset. Solution number 2 is to use a backend server to handle filtering logic with a cached data. This approach reduces dependency on the database and speed up filtering. And solution number 3 is perform filtering on the client side within the user's browser. While this minimizes server load, it's not feasible for a large dataset due to the data transfer overhead. For comparison, we can say that solution number 1 is easy to implement but inefficient for a large-scale system. For solution number 3, it's fast for small datasets but struggle when the data size increased. And solution number 2 strikes the best balance. By moving filtering logic to the backend and leveraging caching, we reduce data database load while maintaining scalability. So focus on the distributed architecture. It's based on the distributed architecture that included three main components. The cache stores pre-compute data to the reduced database queries. The filter estimator model handles filtering logic and ensures efficient result. And the database maintains the core product data. This architecture distributes the workload efficiently, improving performance and scalability. The benefits of the distributed architecture: it's a performance that handles high traffic efficiently, reducing latency. Scalability supports growing data sets and promotes adaptation to cloud environments. And cost efficiency, reduced reliance on the expensive database operation by optimizing server and cache usage. So the filter estimator model is essential to this architecture. Its role is to handle the complex filtering logic on the backend. Yeah, how it works. As the input, the cache arrays of product IDs linked to the filter option. For the processing, it calculates intersection of those IDs based on the user selected filters, and as output, it gives us a refined list of results matching the criteria. This model is designed to handle even the most complex filtering scenario efficiently. Caching strategy is the main problem. So the main problem of the algorithm solves its prediction the number of results for any combination of selected option. Usually, if you have already selected several options, then on many websites, next to the selectable option, the number of results when adding this option displayed. Calculating this number for each option in real time often requires significant speed optimization. Caching plays a critical role in addressing this challenge. By storing frequently user data, we minimize repetitive database queries and ensure fast, accurate prediction for users. Implementation: we use the Redis as a high-performance NoSQL database to store product IDs linked to filter option. As for benefits, this approach ensures fast query responses and significantly reduced load on the main database. We are testing this solution in a real-world environment. For the database, we had the MySQL 8.0, for backend PHP 7.2, and the dataset was over 300,000 products in more than 200 parameters. The results were impressive. Page load times dropped from between 0.8 and 1 second to just 0.15 to 0.3 seconds, even for a section with 1,000 of products and filtering. So those results demonstrate significant improvement. For performance, it's reduced load time and improved scalability. And for the user impact, faster page loading times enhance user satisfaction and increase engagement rates. This shows that the proposed solution is not only effective but also practical for large-scale implementation. For a practical example, to illustrate it practically, we implemented this approach in a real-world project with a large product dataset. Redis caching significantly improved the responsiveness on filter-heavy pages, and impact with page formation speed increases by an order of magnitude, making the user experience seamless and efficient. As a conclusion, the new architecture for web application was designed with a robust backend filtering model that significantly improves web application performance. This distributed architecture reduces page time load and database dependency. Future research will focus on enhancing caching strategy and optimizing filtering logic further. Thank you for your attention.
Daria, thank you for your report, and we are waiting for questions. Questions, please. Well, again, I think that it will be possible to discuss all the reports and presentations after the end of the work of the section. And now to maintain the time schedule, I propose to move forward. And next presentation, it's actually one of my reports with co-authors, and the topic is method of naming of multi-volume files based on Blake 2 cryptographic hash function. Andriy?
Good day, everyone. I am Alona Chepelevich, and I'm honored to present our work on the method of naming multi-volume files based on the BLIKE2 cryptographic hash function, alongside my co-authors, Artem Perepelitsyn and Andrei Litvinov, from the National Aerospace University Kharkiv Aviation Institute. Here you can see our contents of our presentation, and without further ado, I will give the word to Andrei.
Thank you. So let's talk about the large-scale data systems that are central to modern computing, and they face unique challenges when it comes to indexing and managing files, particularly multi-volume files. These challenges include compatibility across file systems and maintaining performance, also ensuring data integrity. Our work aims to address these issues by unifying the naming and storage process for multi-volume files, to ensure the compatibility across diverse file systems, and simplifying file identification. This is achieved by leveraging cryptographic hash functions, specifically the BLIKE2. Next slide, please. And our objective is to unify and simplify the naming of the storage files in the multi-volume formats, and to address challenges in identifying and organization. Additionally, we aim to ensure compatibility with diverse file systems such as FAT32, XFAT, and UDF, maximizing usability across different platforms and operating systems.
Let's begin by exploring the core issues. The first one that we have, compatibility challenges. So different file systems have varying capacities and constraints. Then we'll have performance bottlenecks. Efficient identification and access of files are critical in large systems. On the other hand, file tampering or corruption must be detectable. And systems must handle growing data volumes seamlessly. Then we'll have hardware limitations and data recovery risks. So ensuring file integrity and recoverability is really essential. And these challenges underline the importance of a robust methodology for naming and identifying multi-volume files. Our goal is to develop a unified approach to naming multi-volume files. The tasks we addressed include analyzing cryptographically strong hash functions for file naming, evaluation file systems for compatibility with multi-volume files, proposing a simplified file identification method that avoids recalculating checksums, presenting a name methodology with practical examples. And for the next slide, I will give a word to our colleague Artem.
Thank you. Well, to address the mentioned issues, it's necessary to find the possibility to solve the problem of transferring and processing of some blocks of files. It means that the large file can be divided by small chunks, and most of well-known data processing systems and well-known storage systems such as Google Drive and OneDrive and etc. Use such approach to reduce and simplify the process of transferring, checking, and indexing of files. And it requires the calculation of checksum for each single block of such chunks. And at the same time, it's necessary to represent or map this checksum and information about the such file chunk that we propose to call volume or file volume inside the metadata to entire file and the set of files. And to also ensure the simplest way of the processing, it's necessary to find the naming of such files with lowest number of symbols and most compact representation, with ensuring the security and the possibility and guarantee the unique features of such files. And to do it, it's possible to consider cryptographical hash functions, and based on some of those features to perform such naming and identification of such files. During the current study, the following functions were considered. Those functions, in addition to CRC 16, 32, and 64, well known and can be used for calculation of checksums for the files. And while MD5 is already compromised and the method of compromising is published, the rest remain the possibility of the practical use, but the performed analysis includes the comparison of the cryptographic strings and at the same time the possibility of identification or use of such cryptographic hash function for identification of files. And based on this result, we can propose the possibility of use SHA-3 with some specific widths of the data and Blake 2 cryptographic hash function to perform both identification of file by naming and ensuring of some strong representation or the possibility to be secure and ensure the uniqueness of such result and value of hash function that can be compromised easily now.
So here we can see the overview of each file system, such as XFAT, FAT32, UDF, NTFS, and ext4. And we want to say that XFAT stands out for its wide compatibility across different platforms, while FAT32 remains universally supported, but limited for larger files. UDF is optimized for optical media, and NTFS excels in Windows environments with partial cross-platform support. And ext4 dominates in Unix and Android systems, but requires third-party tools elsewhere. This table highlights the varying degrees of support for each file system across platforms and emphasizes on their trade-offs in compatibility and usability when choosing a file system for specific storage scenarios. To maximize the compatibility, we evaluated the most popular file systems based on our performed analysis, and we can say that XFAT is ideal for large files and wider support. FAT32 for its simplicity and ubiquitous but limited for large files, and UDF optimal for optical media and archives.
Well, based on the performance analysis, it was found that it's possible to use the existing information from the archives headers or even archives reports to perform some practically used identifying of files for non-critical applications. It's possible to combine the lowest 32 bits of the file size information with CRC32 together in entire 64-bit field of size of machine vault to ensure the identification for some practical use that allows to perform the using of the existing information for indexing across big data sets with a lot of files in such archives. And because of the remaining unchanged the file size during the modification during the disk failure, it's possible to identify thus file based on the first part of such file information, and in this way it's possible to find even the file after some corruption to identify it across the rest files. But the disadvantage of this method is the possibility of compromising of this identifier. Because of that, it's possible to propose the following method. To guarantee the unique identifier for each file based on the content, it's possible to propose the following method. It's possible to use the Blake 2 cryptographic hash function and perform the naming based on the groups of 5 bits across the width of 256. It allows to reduce the total number of the required bits because it's possible to reduce the number of bytes for representation from 64 to 52. That allows 19% reduction of the size of metadata files for such files, with maintaining guaranteed identification of the files and with containing of the checksum inside the file name.
In conclusion, we have following things achieved. Volume-based file segmentation and metadata simplifies storage management. XFAT, FAT32, and UDF are the most practical file systems for our method. Blake 2 provides robust and reliable file identification, and combining CRC32 and file size offers a quick identification mechanism. Use of proposed method allows to save up to 19% of metadata size. In the future work, we plan to explore advanced encoding techniques and enhance integration with the diverse archive formats and systems.
Thank you for your attention. We are happy to answer any questions or discuss our methodology in detail.
Yes, and we're happy to achieve the questions. Bogdan, please.
Good morning. Thank you for your speech. Just one question. Do you have any plans to consider distributed file systems? Because metadata in distributed file system is like huge, and it might be useful, for example, for GlusterFS or CEF or something like this.
Or IPFS and so on and so on. Yes.
Yeah.
This idea is a part of this research, and it was considered also. But exactly in this report, we provided ideas for most or highest compatibility between platforms, and mentioned that file system allows to ensure this compatibility, and the ways of actually naming of file volumes or file chunks. But the distributed file systems are also considered, and thank you for this actually idea, and we will focus also on it, I think, in following investigations. Thank you.
Yeah, thank you.
Okay. While no more questions, we are moving forward, and the next report is also with my co-author, I mean with Vitaly Kulanov, with the title "Method of Deployment of CI/CD Pipelines for RTL Design Flow with FPGA Technology." We will be happy to provide results of the investigations.
Okay, hello everyone. So I believe you can see my screen. And yeah, good morning. It's exciting to be here to discuss various topics that are becoming increasingly important. And as Artem mentioned, our topic for today is method of deployment of CI/CD pipelines for RTL design flow within FPGA technology. This is some brief outline. Let's start from introduction. Field programmable gate arrays, or FPGAs, have been around for several decades, but recent advancements have brought them to the forefront of industries like telecommunications, automotive, artificial intelligence, and more. FPGA allows us to create highly customizable hardware solutions that can be reprogrammed to meet specific application requirements. However, with this flexibility, we have some challenges. As we look at these challenges in FPGA development, it's clear that several factors can make the process more difficult and slower. These challenges are critical to understand because they form the foundation of why we need modern approaches. Let's go through these challenges one by one, like time to market, complex design flows, inefficient testing and validation, resource management, rapid technology advancements, and so on. All these issues must be addressed, and the question is how we can do this. As we look and now that we've outlined these challenges, the next step is to explore how we can adopt CI/CD practices and help us to address these pain points. CI/CD has been a cornerstone of modern software development, as you know, and it holds significant potential to streamline the FPGA development process as well. By automating various stages of the FPGA design flow, from testing and synthesis to deployment, we can significantly reduce development time and improve product quality. Given the challenges in FPGA development we've just discussed, there is a pressing need to adapt modern software development practices such as CI/CD to the world of hardware design. Our goal is to bridge the gap between traditional hardware workflows and the more agile automated practices that have revolutionized software development. This will enable faster, more reliable FPGA development process. Now let's dive a little bit in the RTL design flow, which is basically fundamental for FPGA development. The flow typically includes design. In this case, we are writing some RTL code. It can be some of HDL language, either VHDL, Verilog, System Verilog, etc., etc. Another step is simulation, like running simulations to verify that design behaves as expected in various conditions. Another step is synthesis. In this step, we're converting the RTL code into gate-level netlist that can be implemented on the FPGA. After that, we have this place and drop step, which is the mapping for the design to the physical FPGA architecture. And the last step is bitstream generation, creating the bitstream file that will configure the FPGA hardware. So integrating this flow with a CI/CD pipeline allows us to automate much of these processes, from running simultaneous automatically through triggering synthesis and even generating bin streams. All this within a single pipeline. Let's look at how an FPGA-based product design fits into this CI/CD flow. Traditionally, product design is done manually, with each step being validated through separate tools. However, by using a CI/CD pipeline, we can automate many of these tasks, ensuring a seamless flow from development to deployment. Okay, let's consider some practical use case to tie everything together. Here you can see how code review process and appropriate configured pipeline can enhance HDL project design flow. In this particular case, we're using Get code review plus several pipelines configured. Those pipelines currently are checking several specific linking rules for HDL code. And as you can see, a much part of this process is done automatically, so there is no need every time to test whether tests were passed, like let's say whether the name of the variable meets our requirements, etc., etc. To support this process, there is a dedicated architecture based on Docker containers. As a conclusion, FPGA development has unique challenges due to this inherent complexity of hardware design. However, by adopting CI/CD practices, we can streamline the development process, automate testing and deployment, and improve collaboration between hardware and software teams. As a key takeaways, CI/CD can be applied to FPGA development, just like in software development, to reduce time and efforts. Automating key steps like simulation, synthesis, and bitstream generation can dramatically improve development efficiency. Also, integrating FPGA-based product design into CI/CD pipelines ensures faster feedback, reliable testing, and more predictable releases. So thank you for your attention. Any questions?
Thank you for providing the results of the investigation. Actually, I take part in this process for this investigation also, and we will be happy to answer for the question regarding the provided ideas of pipelining and automation of the process of continuous integration and continuous delivery for hardware description systems and languages. So questions, please. Well, again, I think that it will be possible to provide the maybe questions and maybe discuss the existing results, new ideas, and the presented report after the end of the work of our section. And we move into the next report. The next report is titled Model of Network Configuration for IoT Devices.
Hello.
Yes, we can see you, hear
Okay.
you, and you can start the full screen mode. And yes, everything is okay, please.
Okay, my name is Maxim Zalisky. I am professor at the Department of Telecommunication and Radio Electronic System at the State University Kyiv Aviation Institute. And I am presenting author for the report by Serhiy Chumachenko, Bogdan Chumachenko, Romana Darchenko, Marina Malplayet, me, and Alexander Bondarev, Model of Network Configuration for IoT Devices. So here you can see the paper outline. It consists of introduction, related works and problem definition, materials and methods, improvement of the model, and conclusions. So nowadays, the capabilities of network data transmission technologies are growing rapidly. The use of fiber optic communication lines and broadband wireless technologies allows for increasing the amount of transmitted information and improving the quality of communication channel with minimal distortion of useful signals. The main technological advantage of modern optimal network technologies are the possibility of obtaining a given bandwidth. One moment, please, sorry. The possibility of obtaining a given bandwidth and high speed of information transmission, low cost compared to previous means, thin cable diameter, and better reliability characteristics. While using the IoT devices, there are currently many important and necessary tasks to solve, including development of reliable cybersecurity measures, ensuring data confidentiality, development of information transfer standards in network infrastructure, network connection optimization development of data processing technologies, increasing the reliability of functioning of IoT devices, introduction of autonomous power supply system, and reduction of electricity consumption. The development of network configuration model for IoT devices is an urgent task in today's digital world. The main reasons that motivates us to solve this problem were the need to create a reliable, secure, confidential, and effective network structure with the possibility of collecting information from sensor and their communication with each other, the possibility of taking into account the placement points of IoT devices in the certain building, and the possibility of reducing costs during the deployment of the network infrastructure. So the purpose of this paper is to synthesize and analyze new model of network configuration for IoT devices that can be implemented in the multi-story building. The functioning of such a network is described by the routine of messages from the source node to the receiver node, Such transmission is possible only when there is at least one route between these nodes. To describe the model of node interaction in the network, it is necessary to estimate the level of attenuation of the signal by interference at a specific location of the node. Therefore, it is necessary to focus on the fact that the level of interference power will be much higher than the level of natural thermal noise. Thus, it is better to choose an empirical attenuation model to estimate indoor attenuation according to equation 1, where ρ is a distance, f is a frequency, epsilon is a lower loss factor, lambda is a coefficient of loss due to the passage of the signal through the obstacles, and m is a number of obstacles. The analytical model of the interference signal formation, transmitter power at the network node, is described by the expression for 3 dimensions, so you can see it here according to this formula 2, where ρ with tilde is the interference power generated per unit volume, and coefficient gamma determines how the interference power at point O depends on the coordinates of the interference source. The dependence of the coefficient expressed in terms of the distance to the source can be found according to equation 3. And in this case, to simplify calculation, we use the discrete model of our network. So we can go from the 3-dimensional integral to 3-dimensional sum according to equation 4. And if in the qubit lattice the dimensions of the elementary cells are equal to height h, width v, and length L, then the distance ρ between the observation points and any lattice node can be described according to equation 5. And then the equation 3 for the power reduction factor can be expressed through the subscripts as follows. You can see it according to equation 6. The expression for interference power at the point of observation can be written as follows, according to equation 7, where P is the interference power generated by node XYZ at the observation point, L is the load intensity, M is the number of network nodes, and I is an indicator function that ensures that only signal strengths perceived as interference are summed. So in this case, for indicator function and interference power, we can write the following expressions. And after that, we can analyze the dependence of interference power level in a node of the number of nodes in the network and traffic intensity according to equation 10. So you can see the following family of dependencies in the figure 1. So the graph in figure 2 shows that when approaching the real values of the nodes number, the traffic intensity and the attenuation of the interference signal for neighboring network nodes reaches a minimum value to 20 decibel. And in most cases, this level ensures sufficiently high quality of the radio channel when using IEEE 802.11 AC standard. With this signal-to-noise ratio, in this case, the attenuation of signal by interference, it becomes possible to operate at the maximum possible speed. So a quantitative characteristic of the lattice is its ability to pass or facilitate the passage of information. So in modeling, infinite lattice are often used, that is, those with an unlimited number of nodes and connections. The occurrence of percolation is explained by the creation of percolation cluster inside the medium. And while building the lattice model, it is assumed that lattice cells can be divided into 2 types. The first type can promote percolation, and the second type is unable to contribute to this. So the bandwidth under consideration is quantitatively characterized by the parameter known as percolation threshold. For lattice with finite site, this threshold is stochastic and is within the range of volume of our observation. So, however, as the number of cells k in the lattice increase, this range becomes narrower. And for the numerical characteristic of this ability, a parameter called the percolation threshold is used, which numerically corresponds to the fraction of cells capable of performing the flow of function. So in this case, we can use the following equation for our volume V and corresponding threshold value, where R is indicator of correlation radius, which depends on the dimension of the problem. So in our case, we have 3-dimension problem, so R will be in range from 0.8 to 0.9. So the value of threshold is a critical threshold of the share of conducting nodes, which indicates the transition state of the lattice from the non-conductive to conducting. This value varies for different types of crystal lattices. The transition of the medium from the non-conductive to the conducting state occurs at a minimum change of threshold value, which is the point at which the phase transition occurs when the proportion of conducting cells approaches this threshold. This transition occurs in a narrow range of these values, and this description of the model indicates its formal nature, which makes it suitable for a wide range of applications. For the above IoT network model in a multi-story structure, the network is depicted as a grid. Nodes within these grids are communication network nodes, which can consist of individual nodes or group of nodes located in different rooms throughout the multi-story building. Connection between nodes are channels that can be established between neighboring networks nodes. So a model cell in the room is classified as conductive if it has a working network communication nodes, and non-conductive is there no such node. It is assumed that connections are created exclusively between neighboring nodes, that is, nodes located in neighboring rooms. For the building to have a connection network, it must have a population cluster consisting of adjacent conductive cells. Exact analytical solutions are currently known only for a limited number of specific examples of two-dimensional lattice. So simulation methods are used to study the behavior of different types of lattices. There is a considerable quantity of numerical results obtained from the simulation of different types of lattices. And for example, the percolation threshold for this basic cubic lattice, which is commonly used in network modeling, is denoted by the threshold value. So in the studied model, this value can be interpreted as a minimal share of premises in the multi-story building, where working nodes of the network must be placed to ensure communication between all nodes of the network, thereby ensuring network connectivity. So the proposed model of the network of IoT devices presented in the form of grid is logical basis of structuring connections between nodes located in different rooms. The network configuration is determined by the building layout. The obtained model makes it possible to evaluate the efficiency of communication channel using the PSP estimation and the overall signal-to-noise ratio for network nodes. The use of the model allows to confidentially state that in modern multi-story structure, if the nodes are placed in each room, it is quite possible to create a wireless communication network. In addition, the quantity of the radio channel allows to use data transfer rates that meet the highest standards of modern technologies. The principles of percolation theory can be used to explain the three-dimensional network model in a multi-story structure or other similar structures. The fundamental properties of percolation structure can also be used to analyze the properties of communication network. Thank you for your attention.
Thank you for your report, and actually this is a too relevant topic, and I hope that we also will be able to see the continued investigation of the problems of actually distribution and actually modeling of the possibility of the connections of IoT devices within the rooms and actual cells. And the question, please. Well, actually, maybe one question from me. What, or maybe, okay, what the kind of the transmitters are involved to the consideration of the connection for those devices?
Okay, thank you for your question. So in our university now we are launching the 5G laboratory, and we use the equipment that we have for this laboratory. So we have some support from communication companies, and we use all the equipment that can be used for 5G communication network. So we make some measurement already for different rooms in our university buildings. So, and try to analyze the bandwidth, the influence of noises. So we use 5G equipment for this study.
So actually, it's a directed lattice and directed transmitters, and actually, it's a completely really implementation of 5G cells, right?
Yeah.
It's too interesting, and we are waiting for the results of those investigations. Well, thank you for providing all the results of your reports and study. And I will ask to provide the results of the next speaker, and the following report is algorithms for controlling the modes of highly efficient hybrid mobile power complex.
Доброго дня. Вибачте, у нас доповідач не може підключитися зараз. Прошу перенести на 12:30 нашу доповідь.
Well, it's possible, but is this topic will be presented? Скажіть, чи буде доповідь зроблена? Тобто ми будемо чекати, але...
Так, на 12:30 буде.
Добре, чекаємо, нехай буде, або нехай надішле запис.
Дякую.
Чекаємо. So the current report can't be presented at the moment, and we will be able to hear the report in 30 minutes. And now we're going forward, and the next topic is using secure infrastructure for unmanned intelligent system to support mine clearance.
Yeah, good morning, everyone.
Please.
Can you hear me?
Yes, and we see the presentation. Please go ahead.
Perfect. So my name is Bogdan. I'm a PhD student at Kharkiv Aviation Institute, and I want to talk about how secure unmanned systems can help with mine clearance. In Ukraine, as you know, many landmines and unexploded ordnance pose a serious threat to people, so the problem is really relevant. I'm going to introduce a hybrid methodology called AI/UAV DevSecOps, and also some key security metrics we must prioritize be highlighted. And let's begin by looking at what we already know about demining challenges and how unmanned systems can step in. Speed and safety are vital. The longer explosives remain in place, the greater the danger to human lives. UAVs can quickly scan and map large areas using sensors to detect explosives while keeping operators at safe distance. When paired with AI for real-time detection, UAV data collection becomes even more effective, and of course security, including cybersecurity and safety, is crucial, which we'll discuss later. And right now I just want to voice one quote without mentioning its author. I think the people in Ukraine have felt its meaning over the past couple of days. The role of cybersecurity is a bit segregated, and thoughts like this are a big problem. And another problem is that we face a challenge in effectively integrating UAVs and AI with IT and security considerations due to the absence of a holistic methodology. while some frameworks for IT processes and infrastructure exist, they aren't widely adopted in scientific projects and aren't often seen, they often seen merely as a utility. Moreover, many projects lack a support culture, concluding after implementation without any long-term planning. That's why I want to propose the AI UAV DevSecOps methodology, which unites AI development with continuous security and operational best practices. As we don't have so much time, I cannot describe all the details, but most of us know what DevSecOps is. Let's add the AI requirements here, focus on working with infrastructure and a bit of science, and we'll get an understanding of what this methodology is. And first of all, risk assessment, threat modeling, and vulnerability analysis as a part of security. These are essential methods for identifying, evaluating, and mitigating potential security threats. Risk assessment prioritizes mitigation strategies by analyzing threats and their impacts, while threat modeling creates predictive scenarios to develop defenses, and vulnerability analysis can be performed at any stage of the system lifecycle, ensuring timely remediation of weak points. The comprehensive reliability indicator measures a system's ability to function without interruptions, considering factors like equipment stability and the capacity for self-recovery. Key CRI metrics include availability, utilization, readiness, and maintenance repair labor intensity. Beyond reliability, data integrity preserves information accuracy through encryption and authentication, while cybersecurity protects against threats such as hacking or malware. Operational security governs safe system operation via access control and system monitoring, and functional safety ensures proper performance without endangering users through regular testing and audits. AI infrastructure may be different, but each requires sufficient and fast data storage, networking, and resource management to support large AI workloads. Detailed planning ensures system scalability, performance, and security through measures like encryption, access management, and user authentication. The system infrastructure development lifecycle offers a structured approach to infrastructure design, deployment, and retirement, adopting standard SDLC steps to accommodate security and reliability needs. It covers all stages from requirements gathering to decommissioning, ensuring that each phase addresses infrastructure-specific concerns. And while SIDLC emphasizes technical aspects, CVA IM focuses more on management, communication, and adherence to requirements. When working on projects, we have a lot to learn from business, and communication is one of important things, as well as continuous planning and support culture. 4 of 5 steps of this approach is communication. The proposed methodology cannot resolve every challenge in deploying mobile intelligent monitoring systems, but it can address pivotal technical and organizational issues by focusing on cybersecurity, component integration, and long-term planning. Adopting a strong support culture also lowers maintenance costs and streamlines processes. Although social aspects lie beyond the primary scope, engaging with scientific and educational communities can help probably promote modern approaches and higher technological standards. This methodology not only meets immediate needs, but also creates a foundation for broader systemical improvements leading to more resilient and efficient monitoring systems. That's it for me. Thank you for listening, and I would be happy to answer your questions if we have time for that.
Yes, thank you for your report, and questions, please. Well, it looks like no questions. Well, if so, we can move to our next speaker. Actually, this report is where I also co-author, and it's titled Analysis of Nomenclature of Microcontrollers, Decision-Making During Building of Home Automation Elements. 10 minutes, please.
Okay, thank you. Greetings to our audience. We are glad to meet you on our conference. My name is Alexander, and today we want to present you a report about our analysis of microcontroller nomenclature. Is my presentation seems clear?
Yes.
Yes, thank you. While reporting, we will motivate our research, set its goals and objectives, define some terms for comfortable description for manufacturers and their products, of course, analyze the difference, and propose the decision-making procedure for their application. So, for the best practice, it's necessary to use an optimal hardware for developing solutions. But with development of manufacturing companies, knowledge bases require in periodical updating. Therefore, the existing list of microcontrollers need to be considered according to their application specifics. In that case, the goal of our investigation is to analyze the product range of modern microcontrollers for building components of IoT and home automation systems. To achieve that goal, the following tasks should be solved. They are: define the terms and significant features of the microcontrollers, analyze the product range and the list of modern manufacturers of the most common microcontrollers, analyze the main features of most popular AVR, STM32 and ESP32 microcontroller series, compare their hardware resources, and propose a decision-making procedure for their selecting. In terms of basic definitions, a distinction should be made for microcontroller as a single chip with one or more cores, different types of memory, external ports, peripherals, and other hardware resources. A series of microcontrollers, it's a union of microcontrollers with similar name or part of the labeling. And family, it's a union with similarity in architecture and instruction set. In component set terms, we need to define a program memory. In modern solutions, it's represented as flash, a non-volatile memory or EEPROM, and static memory. And we should notice that three of those terms will be used in model comparison later. For manufacturer analysis, 14 companies were considered. Each provides a rich series sets of their unique products, but most common are considered the following is are aware, STM32, and ESP32 series. So what actually aware is? It's a family of tiny microcontrollers with improved energy efficiency, simplicity, and speed characteristics, but its memory reserves and poor support for complex computations. For STM32, we can describe it as a family of powerful microcontrollers with improved level of performance, computing capabilities, and rich set of communication interfaces. Of course, such improvements causes increase of complexity, power usage, and science dimensions. And for ESP32, it's a series of network-adapted microcontrollers with extended toolkit for inter-device wireless communication. Equipped with significant memory capacity, this series has the most power consumption and size dimensions. To illustrate a difference between described devices, it can be represented as range comparison of their hardware resources. And here the main diversity can be noticed, which could be used in the decision-making procedure. For developing solutions should be considered the resource requirements, amount of built-in flash memory, the absence and need in EEPROM usage, a number of pins and digits, and of course RAM or its analogy. It's also need to be noticed. And according to those parameters, it becomes possible to narrow down the scope of allowed controllers the same way as it's shown on examples on slide. In conclusion, we can admit the following task done. The existing microcontroller manufacturers and their products were listed and analyzed. The hardware resources of their products for each nomenclature was considered. Comparison of its physical characteristics and resources between described series was listed and analyzed. Proposed a decision-making procedure for rational microcontroller chosen, and shown in some examples. And that's all for now. If you have any question for me, I would like to answer them. Thank you.
Thank you for providing the results of the research we are also taking part. And questions, please. Ivan, question, please.
No, first of all, thank you for the presentation. I have a question about the boards that are commonly provided to the microcontrollers. Were they taken into account when doing the research, or exclusively the microcontrollers?
Can you repeat your question, please?
Were the standard boards for given microcontrollers taken into account for the research?
Where we described those boards, or where
were they taken into account, the specific boards, for example, for ISP32s or AVR, etc.?
I will try to transfer the question. The question is actually, did we consider the microcontrollers with boards together, like the radio solutions?
Yes.
Actually, Alexander, I think that you can provide the answer. I mean,
as a part of platforms or something like that. Yes, for example, Arduino platform and yeah, something like that. Actually, in this case, we described microcontrollers as itself. Of course, there is some difference in representation in form of different sockets, different plates that also can have an influence to decision-making process, but for ordinary user, for example, student or single engineer, it's not to be a problem to resize his solution and adapt it for platforms that actually were produced. If I understood your question correctly.
Yep, that's correct. Thank you.
Yes, thank you for providing the results. And actually, I think that we can move forward to the next presentation. Well, actually, according to the schedule, the next presentation should be provided by my student, where I'm a scientific advisor. But because of the technical issues, I will actually provide the results of the research, and I will transfer actually the results of the investigation and prepared system. And actually, this presentation, was prepared by the student, but I will provide the results. So let me to actually bring the current results of the investigation and the practical application of the those results connected with the analysis and search of the possible way of the convenient communication for home automation system or systems with a smartphone. And actually, the initial idea of this research is to find the simplest and easiest way for the end user for communication with the home automation system, with ensuring the simplest way of the this process of the control and receiving the results of the control back, and to make possible to reproduce of such results during the creation of such systems. So actually, to do it, the following set of issues were considered, including the requirements of the problems of the communication, existing and spread technologies and protocols and interfaces, including Wi-Fi, Bluetooth, NFC, and infrared data acquisition, and so on and so on. And based on those results, actually the problem was formulated, and the purpose of this research is to analyze the possible ways of interaction between the built-in systems as a part of the smart home and the smartphone. And to achieve of this goal, the following tasks were formulated. Actually, the analysis of the existing technologies were done from the point of view of applicability of those technologies for use with the common and maybe cheapest smartphones and allow most of users to perform the control of the home automation and smart home elements. And the following set of the technologies were considered, including the Bluetooth, infrared port, optical channel, this is visual light communication, sound channel, QR code reading and providing the pictures, and of course technologies 3G, 4G, and including 5G, GSM, and also CDMA technology. For those technologies, not only the applicability, but also the possibility and range of communication is considered. And it's also important to take into account the possibility of work of some technologies in the completely local scenario of use. I mean that it's possible to use some elements of the smart home without the internet connection. So in this case, we can consider this kind of automation like IoT completely. And while we trying to use this offline, it's necessary to focus on the technologies that allows the autonomous work while the internet connection is unavailable, including the scenario of use while the centralized supplying is also not possible. And because of that, the following set of interfaces were selected, including the most interesting, like visual light communication, actually infrared channel in form of infrared data acquisition, and the rest popular interfaces. I mean the possible solutions that present in the modern smartphones and at all kinds of smartphones. And because of that, the following assumptions of the throughput are used, but it's not the exact values because it can be changed, especially for some of them, depending on the way of the processing and the quality of the equipment. And actually, based on those results, the element of the home automation in form of controlled blinds were prepared and prototyped based on the two technologies. Priority was done for the infrared communication for control of such blinds. And actually, for prototyping of such solution, the idea of infrared communication was selected, and the possibility of control of such solution within the direct visibility. And to ensure the autonomous power supply of such system, the charging from the solar daylight was selected, because based on the calculation, it's enough to ensure the charging in the current selection, current consumption mode of current, enough even during the winter. And actually, the based on the student project, the following set of components is involved to the creation of such system with actually implementation of the project itself based on the Atmega 328 chip with a real-time model for obtaining the time to schedule the actions for blinds during the day and week. Actually, infrared receiver, servo motor for actualization of the position, TP4056 charger, and 18650 lithium cell for actually accumulating the energy from the solar panel. And the prototyped circuit for the automation of blind system actually includes a combination of all the mentioned components and allows the work. And here it's not presented actually transistor here in this power line, but it's also can be or should be added to ensure the possibility of deepest sleep mode of this microcontroller to achieve the power consumption of 150 nanoamperes. And in this mode, it's enough to use the solar panel for charging of those systems. But periodically, it needs the waking up for checking the state of the infrared channel communication, and this task can be done by external interrupt, and actually the interrupts configured from the real-time clock model. Well, based on the performance investigation, the technologies for local interactions and interactions with a smartphone in the easiest way for the user were considered, and it was concluded that infrared channel, visual light communication, QR codes, and Bluetooth are most promising technologies for local communication without the connection to the internet. As well as Wi-Fi technology can be also used if the chip is support this communication. But in this case, as was mentioned, it's necessary to use a chip with support of wireless communication. And it's also possible to use GSM and CDMA technologies for communication if it's a kind of the security application, I mean the safety security, and safety issues, I mean the monitoring systems and so on. And based on the considered ideas, it was proposed and prepared the circuit for control system for blinds, and actually the prototype is created. Thank you for your attention, and I will be happy to answer for the questions. Questions, please. Well, if no questions, we will move to the next speaker. Actually, it's next report with also where I took a part, and the title is Analysis of Redundant Encoding Implementation for Serial Communication for Microcontrollers. Ivan, you have 10 minutes to present the results of your research.
Okay, thank you. Greetings, dear listeners and guests. I present you the analysis of redundant encoding implementation for serial communication of microcontrollers. This research was conducted by me, Ivan Didenko, and Artem Perepelitsyn. And not to waste time, I'll start with the presentation. We'll begin with the relevance of the topic of this work. It's hard to underestimate the importance of having faultless data transmission. Most of the systems count on the fact that any data that's been transferred or delivered to them via another device in the ecosystem or any system is faultless and contains valid information. And any interference in this transfer channel is considered an exception rather than a normal occurrence in the program. And that is partially achieved by having interference-resistant communication channels. One of the tools to achieve this is redundant coding. The data below shows the relevant markets of embedded systems and smart houses, and the fact that they have a positive growth velocity, and that this sphere is rather developing and promising to implement this technology. And without further ado, redundant coding at its basis is the process of adding a certain amount of extra information that has some kind of connection to the informative part of the message, creating a so-called code word. And that's made to have the possibility to restore altered data at the point of data retrieval or to detect any errors. A lot of different algorithms were researched and used for decoding. Their main goal is to create enough Hamming distance between code words to ensure that the algorithm's logic is able to fix as many errors as possible. And that is achieved by computing complex relativity patterns between bits in the code word. Here you can see the goals of this research. This work aims to analyze current mathematical models and solutions to create a better implementation of an interference-proof UART serial communication channel via microcontrollers, and namely software serial communication. And let's continue to the analysis of these redundant codes. Redundant codes can be roughly divided into three categories: early redundancy codes, like Hamming code or Golay code, that were created in the middle of the 20th century. Semi-modern codes. The prime example of this category is the famous Reed-Solomon code. They were created in the end of the 20th century. And the modern codes, like turbo code or low-density parity checks. Modern algorithms tend to be a bit too difficult to compute using microcontrollers for autonomous systems, while simpler codes lack the rate of data transfer and the ability to correct a large amount of errors. Following that review, the basic principles of coding in these algorithms are shown. Early codes use purely logical models or simple matrix operations or mathematical so-called games like binary Golay code, while other algorithms use progressively more complex ideas like operations over Galois fields or polynomial operations or even multidimensional geometry. Their efficiency can be seen on the next slide. As can be seen here, older codes like Hamming code, Golay, or quadratic residual codes tend to have lower rates of data transmission, so somewhere around 0.5. While newer codes like Fire code and Reed-Solomon code have better optimized transmission rate. Additionally, it can be seen that the mentioned codes are flexible. The code word size is variable and they can be changed, thus modifying the characteristics of the given code. This unique feature brings a lot of variability and viability to these codes in any implementation, both autonomous systems or not. And talking about implementations, let's shift to the core of the topic, microcontrollers. They are the driving factor of the system and both a limiting force. Microcontrollers' characteristics dictate how valid a given coding method can be. Additionally, it's necessary to mention that it's not an uncommon occurrence to use these microcontrollers in an autonomous system. Thus, it's also important to choose one that can act with minimal delays and have efficient energy-saving modes in order to minimize energy consumption. And those characteristics can be seen here. A tendency can be noted that AVR microcontrollers are a clean winner when it comes to energy-saving modes and reaction time from the deepest sleep mode, because of their 8-bit basis of the CPU. While other microcontrollers like ESP32 have better optimized lighter sleeping modes due to their highly powerful nature of double core, so to say. And next up, I'm going to cover the importance of the choice of the microcontroller. And that is the availability of hardware UART pins. It's clear that compared to general purpose input-output pins, the interface count for this type of connection is very limited. The limiting factor is an open window into implementing software serial interfaces, since the hardware allows for realization of general purpose input and output pins. And talking about UART protocol, it's the most basic serial communication protocol that is based by 2 or 3 wired idea, the third wire being the ground wire. The protocol is based around 5 to 9 bits of message, with the idle state that is being interrupted by start bits or stop bits. The shown picture here is the example of UART with the size of the message 8, with 1 length of stop bit and no optional parity check. But it's not always possible to implement a UART connection due to distance between possible microcontrollers or the amount of interference in the system. So it's valid to look into alternative ways to communicate, be it radio channel or optical, or more precise, infrared channel. And thus the UART protocol should be changed, since the idle state of logical 1 cannot be supported. And thus the start bits and stop bits are flipped, and idle is changed to 0, while the size of the UART message is stable. And thus, to ensure the adaptability and usability of standard hardware UART, it's needed to have the message length of 8 for software UART, because it's possible to have the transmission be delivered from software to hardware if the synchronicity is up to par, so to say. And one of the best ways to implement it is Neo Software Serial library that uses some of the very clever decisions and choices to address the problems of message retrieval, interruptions, and microcontroller freezes on signal waiting. And for universal redundant code, it's possible to use a reduced read-Solomon code using the code word of length 14, 10 length of informational symbols, and the alphabet size of 4 bits. The error correction is enough to maintain a high robustness, and it's effective enough to not hinder the data transfer process. In conclusion, one of the most suitable microcontrollers could be named as Atmega 32-8P or STM32 Series L4, since their optimization and computing power balance. And out of all of the codes, for small messages, you can see Galea and Hamming codes are optimal, and for other messages, read-Solomon code or even Fire code for highly optimized data transfer could be viable as well. Thank you for your attention, And if there are any questions, I would gladly answer them.
Yes, thank you for the providing of the results of the investigation where I took part. And questions, please. We are waiting for questions. We want to share the results and we want to actually maybe discuss it. Well, okay. Again, I think that it will be a lot of possibilities to discuss the results after the end of the section, but for the moment we are moving forward. And Ivan, please stop the sharing. And it's pleasure to me to invite our next speaker, and actually this is also the results of the recent investigation and actually the results of the study and actually the topic of this result is a microcontroller-based system for balancing and monitoring of lithium battery pack.
Okay, can you hear me?
Yes, everything is okay.
Okay, great. So
please,
I would like to introduce my co-author's research, which is a microcontroller-based system for balancing and monitoring of lithium battery pack. With my co-authors, it's Artem Tetsky and Artem Perepelitsyn. So as you can see, we find quite a interesting task which related to lithium battery pack. And you probably know that to have a good support of battery, you need to combine several lithium cells, because one, it's quite low voltage, it's 3.6 or 3.7 volts, it's not enough. And to increase the volume of the pack, it's required to not only serial but also in parallel combining of the elements. And such lithium cells and battery packs are now very used, and also as main battery, and also like some reserve pack to some blackout, something like that. So what is the issue here? So actually one of the most thing here is that all that accumulators, even if they are in the same vendor and date of manufacturing, they have slightly different parameters, and because of it, they can charge and discharge a little bit different speed. And if it's only one single cell, it's not an issue. But if it's a lot of them, so it can be a situation. Then one of elements is slightly discharged, and another one is completely discharged. In that case, that accumulator pack will stop and shut down with low voltage. It can be different causes of it. And it's not only like different batteries itself, but it can be some different heating, different vibration, something like that. So if the battery are the same on the manufacturer stock, they are not the same after years of exploiting. So it's well-known issue, and its issue can be resolved in different ways. A common way is to use some balancer. Is it hardware equipment which allows to review every cell, every parallel cell with its voltage, and if voltage is different than another ones, it means that it's not so good. And it's a decision how to deal with it. So passive balancer, it's one way of using it, and active is another way. So in common, they do the same, but in different ways. And all the ways have another cons and pros. And in common, it's a good solution. It's worked for a long time, but it have some drawbacks, like it's many hardware elements, and they also can fail or some problems with it. So again, that balancer system is not so fine as it could be. So the main idea of our research is to use a microcontroller as a monitoring and probably balancing of lithium battery pack. So why it can be used and what is the main aim of our investigation? It's because it's quite cheap and it's flexible. It does not require so many extra hardware elements. So for the first glance, it looks like it can be used. So let's have a look on existing circuits. So left side, as you can see, it's active, and right side is passive circuit. So it's not like a rule, but it's a common, very common topic and scheme how to reuse it. So as you can see, the active, it's check every cascade and then balancing between them. And passive, it's only turn it on then battery is high voltage and redistribute it in other way. So as you can see, it's or big logic or some power elements with special integral chip. And to review it, it's quite different hardware can be used. On the picture, you can see some implementations. Actually, it's not only one. And I would like to emphasize that you can see the same elements in a row. It means that every of cascade requires specific equipment to handle it. And it means that if we have a lot of serial accumulators, every of it requires its own hardware and some power transistor, or a lot of condensators. So it's not complicated in terms of some high knowledge, but it has a lot of elements here. So it can be an issue to scale it to more cascades. And that picture, one of my colleagues, he set it up batteries with DC-DC converter and charger on the right side. So you can see that balancer and DC-DC is enough to power a laptop. So if 230 volts is required, it's required extra inverter, but this pack is not deals with it. So it's good enough to power laptop and to do all the stuff with the students. So you can see that accumulator, which is packed inside, they're quite different. So some of them are used, and it's much more cheaper than to use new one. And in that case, balancer is more important because different batteries are too different, and they need to be more precisely balanced between them. So from other side, what is proposed is to use a small microcontroller. It's not a very particular model, so it's just one of them. So it's quite small. It's tiny 85, and not every, but a lot of pins of it can be used as ADC. So it can measure voltage with some resistor dividers, and it will have a lot of smaller parts of elements, and also it's quite cheap because it's only one, not a lot of transistors. So yeah, it's a good idea to use it. And by the way, it's they need a software for it. It's one drawback, but when it's created once, it can be used many times. So, and yes, ADC ports will require it for every cascade. So small, it's not enough for every time. So what is one of possible cons of using a microcontroller? It can not only monitor locally, but it can send some data to extra server. So if we have some internet connection, for example, if microcontroller like ESP32, they can onboard a Wi-Fi module. So they can go outside and transmit the obtained data somewhere on the server. And it's good that you can monitor it remotely. So if you have some many batteries in some quite distant or dangerous place, you can monitor it from miles of it, and it will be okay for you. So such monitoring is possible to add extra functionality. For example, some alert, if it's has bigger or discharged or something like that. So it can be raised some interruption, and some customer can have can raise some notification about it. And also, why it can be so useful, it can include different many the same hardware and distributed in different relays, but they after that they can be stored in the same server, and a customer can see it in the one point of everything. So it seems very promising, and we can conclude that microcontroller can be used first for monitoring and probably for balancing with extra hardware. And one of possibilities which provided is to use remote storage and remote observing of it. So it's a good idea to extend the existing lithium battery packs functionality. So this is all from my side, and please welcome with your questions.
Thank you for report and providing the results of the study, and it's happy that there is such possibility. Thank you. And actually, we are waiting for questions, and we will be happy to answer for questions. Questions, please.
Hello. Do you hear me?
Yes.
Yeah.
I know that maybe it's not exactly about your topic, but I believe a lot in natrium-ion batteries. And how do you think maybe you thought about this? Is your solution is also available for natrium-ion batteries?
Yeah, it can be used because the chemistry is different, and it's like a little bit different. Yeah, it requires its own chargers and, of course, balancers. And if we use a microcontroller, it's even more, I think, even more easily, because actually what is the difference? It's the voltages itself and the current, what it can be given or extracted from it. So actually, it's probably even better for us, because we just can replace the firmware of the microcontroller and use slightly different numbers inside it. instead of using different MOSFET, some logic, and so on, so on. So in terms of extending of the idea on the different chemistry accumulator, it's probably also a good point to use it not only for lithium battery. So thank you very much for your question.
Thank you for your answer.
Thank you for question and for providing the detailed answer. It looks like no more questions, and Sergey, thank you for providing the results, and we are ready to move forward, and I think that we can ask the authors of the skipped report, are they available for actually providing the results right now? Наталя Панасівна, скажіть, будь ласка, доповідачі вже можуть зробити доповідь? Наталя, ага. Там Оксана Давгалюк та Андрій Третьяк.
Ніби ще не можемо підключитися.
Скажіть, це технічна проблема чи в чому?
Так, технічна проблема. Людина не може підключитися, бо немає зв'язку і світла.
Добре, але ми чекаємо або на запис, або на запис мається на увазі, якщо є запис відео. Але
Ні, ми не записували відео, бо думали, що будемо так виступати.
Добре, ми продовжуємо роботу, і ще буде така нагода, але обов'язково доповідь має бути представлена хоча б вами.
Так, робота, вона є, в нас є і презентації, і доповідь є. Я ж кажу, не може тільки технічно.
Тоді за 2-3 доповіді, тоді ми чекаємо, щоб це було представлено. Добре?
Ну так, на 12:30 я просила, так, я думаю, що повинні в 12 включити світло.
Добре, тоді чекаємо також.
Дякую.
Так. Well, we are still waiting for providing the one more report from the skipped report from the list of timetable, but we still waiting, and because of that we continue moving forward to next reports. And actually the next report is also the report of just the same authors, and let me to provide actually the results, and I will try to provide the results of our study. Let me 1 second to start the presentation. Okay. Actually, let me to provide the results of our investigation connected with the possibility of improvement the processing of intrusion prevention, actually building of intrusion prevention systems with use of FPGA solutions implemented in form of smart NICs. And actually, thus implementations allow to simplify the processing and filtering of some potential cyber threats it's possible to actually perform the automation and perform the deployment of such solutions within the cloud services and infrastructure. And actually, it's possible to highlight the main elements of such investigation that include the consideration of actually intrusion prevention and intrusion detection systems, the methods involved in this process, and also the tools, and also the consideration of FPGA acceleration boards, and the investigation of the capabilities of modern smart network interface connectors or smart NICs that are capable to perform the functionality of very fast network interfaces to offload the part of the tasks that can be moved from the server logic to actually the hardware level, and it allows the significant improvement of the performance of such solutions. And actually, it also includes the elements of creation and proposed sequence of steps for creation of such FPGA-based implementations of intrusion prevention systems, and also the proposed structure or architecture of the data center infrastructure based on such smart NICs technology. Well, the main features of such elements include the possible detection of some cyber threats and cyber incidents, and actually the process of enrichment of the collections of known risks and signs of such risks. And this process also implemented in form of the existing methods. It's a signature or signature method and anomaly detection method. And actually, considering such methods, it's possible to not only implement the automation of the detection of such kind of intrusions, but also to implement the prevention of such intrusions. Well, at this point, actually, the goal of our study is to improve the performance of network protection of components of modern data centers with the use of FPGA accelerated cards in form of smart NICs. And to achieve this goal, it's necessary to actually perform the following tasks. Well, there are well-known tools for performing the analysis of the threats, and Suricata is one of them. And actually, using this tool, it's possible to perform analysis and actually the classifying of some potential risks in form of the analysis and identification of the possible attacks. This is an example of how the intrusion detection system can be organized and can work. Actually, implementation and improvement of such logic can be realized together with the connection of the software part controlled by one of the supported version of Linux, including of Ubuntu and CentOS, and on the other hand, the FPGA kernels running inside the FPGA chip with PCI Express communication between them to ensure the possibility of really fast communication with the onboard optical interfaces for internet connection with enough throughput for the use in such servers. Actually, such optimization of the processing and detection allows significantly reduce the load of the central processors in such servers to provide those resources actually for the main purposes. I mean the clients of such servers. Actually, to perform such actions, it's possible to use existing smart NICs and the REST FPGA accelerator cards that implemented in form of PCI Express extensions that can be installed to the server. It also can be installed to the ordinary personal computer, and such solutions provides the network interface of with significant capabilities and with a lot of interfaces. For example, Alveo V80 provides 4 interfaces and it allows to achieve some increasable, for the moment, 200 gigabits per second communication. It's a dedicated card for such purposes. There is some universal card for all kinds of purposes. This is the Alveo U55C with a rich amount of HBM memory inside, but at the same time there are 2 interfaces with total throughput of 100 gigabits per second. And there are a lot of different dedicated cards that can be considered as a smart NIC and that can actually be used for such purposes. Some of them are relatively cheap and can be connected together to organize the parallel processing and implementation of tasks of intrusion prevention and intrusion detection in such solutions. There are also solutions from another company based not only on AMD but Intel chips, and such solutions also provide fast enough solutions and interfaces for processing. The comparison of such solutions shows that all of those smart NICs implemented in form of FPGA accelerated card provide the possibility of optical communication using the standard QSFP 28 with different number of connectors, and actually it allows to perform the communication with the supported bandwidths and to perform the processing. Actually, here FPGA can be involved at the level of processing of such elements. I mean, to perform the processing of the network traffic, with providing some results back to the server over PCI Express, or without, with leaving only the communication for configuration and updating the information patterns and some updates required for improvement of the work of the intrusion prevention system. But how to organize such solution? We propose the following architecture of the data center infrastructure with use of smart NIC inside of this infrastructure. Actually, as a hardware part of the data center, some set of such smart NIC based on an FPGA can be installed in parallel and connected over optical lines to the network. And inside, some server logic can be organized, including the set of applications like configuration application and the host application for FPGA. And the main part of the logic of the server can be provided for the general task, including the work of the Docker. And actually, such elements can be also organized like some images or containers. And the main thing is maintaining the hardware communication with the installed solution over the PCI Express. And actually, here it's possible to perform the filtering at the hardware level to reduce the required computational power from the main logic of the server. How to build such solutions? We propose the following sequence of steps for creation of FPGA-based implementation of intrusion prevention system. Actually, at the first step, it's necessary to formulate the requirements and list of network elements for processing, and actually to formulate the requirements for intrusion detection. As a second step, it's necessary to actually perform decide what the type of FPGA accelerator card can be installed. Actually, it's necessary to select the smart NICs and perform the installation and preparing the projects for this version depending on the vendor. On the third step, it's necessary to perform the decision or actually what the set of the elements will be included to such smart NIC solution, and it's necessary to perform the creation of project for such solutions with the use of the tools from the vendor of these FPGA chips. It can be Intel with Quartus Prime, or it can be AMD with tool set of Vitis and Vivado. At the step 4, it's necessary to perform the integration of the host application with FPGA accelerator card into the one of the containers, or it can be implemented directly at the level of the operation system to perform the communication and configuration of such kernels inside FPGA. And at the last step, it's possible to perform the communication and work of the infrastructure as the entire system, with providing to this smart NIC information about the known cyber incidents to improve and ensure the possibility of intrusion detection. So continuously organize the providing of new information from the databases. Actually, based on the performance analysis, it's possible to conclude that there are few methods for detection of the intrusion, and there are tools for performance of such solutions that allows to organize the communication with the hardware level. And it's possible to use fast and improved hardware solutions in form of smart NICs that allow to offload server to provide more computational power for the general purposes of such server. And it's possible to propose the steps from 5 steps of the creation of the FPGA systems for automation of such solutions. And actually the architecture of server infrastructure for creation of intrusion prevention system based on FPGA with smart NICs is proposed. Well, thank you for your attention, and I will be happy to provide the answer for all the questions. Questions, please. Well, again, while there is no question, I think that it will be possible to discuss the results after the end of the work of the section. But now we are moving forward actually to the next speaker. And the next speaker, according to the schedule, is one of my students, where I am a supervisor, but because of the technical problems, he can't present his results directly, and he prepared the video record of the prepared presentation, and I will provide his presentation over the providing the video for the moment. So the next presentation is the analysis of technologies and ways of local interaction of smart home components with the human. No voice, right? Okay. Sorry. It means that I need to rerun. Well, I propose to provide the next presentation and return back to this after the current one. And the next presentation is information technologies for security of business models of transport enterprises.
Yes, a good day.
Hello.
Yes. Just a moment. Could you please tell me, see my presentation?
Yes. Everything is okay, and you have 10 minutes, and we will be happy to see the results of your investigation. So please go ahead.
Okay. My name is Darina Poberezhna. I want to be present my topic for title Information Technologies for Security of Business Models of Transport Enterprises. You see the paper outline, introduction, related works and problem, materials and methods, improvement of the model, conclusion, and future scope. At the current stage of development of science and technology, transportation enterprises are increasingly facing constant security challenges. Information technologies provided tools to ensure the efficiency of transport enterprises business model, monitoring, analysis, and prevention of risk, which make it important tools for such enterprises. The growth of transport operations in large cities and international transportation requires working with large amounts of data, which requires new approaches to managing transport and information flows to improve their security. Modern information technologies in the activities of transport enterprises should perform the following functions. Simplification and improvement of the system of control over production, commercial, operation and financial activities, achievement of competitive advantages, and different levels of competition in the following three areas: resource, operations, programmatic and strategic advantages, forecasting and modeling of activities, quick and adaptive response of management to unstable changes in the external environment. Ensuring the security of the business model plays an important role in the effective function of transport enterprises. This allows improving the indicators in terms of customer focus of the enterprises, improving financial and economic indicators, saving time, production and human resources, economic, financial, and information security. Therefore, the authors of the paper focused on solving the problem of not eliminating cyber threats and cyber attacks on the business model of a transport enterprises in the information environment. Also proposed a mathematical model for applying the zero trust concept on the example of transport enterprise. The paper shows a step-by-step procedure for building a mathematical model based on the zero trust concept using game theory, which minimizes the probability of an attack success and achieves optimal protection based on mixed strategies. The modeling of the use of zero trust concept assumes the following stage. The threat will be modeled as a hypothetical attack by an attacker who can use a finite set of strategies. To develop an effective cyber system, the enterprises can also apply a finite number of strategies. The list of threats and defense strategies was complied based on analysis of sources and survey of experts. The assessment of threats and the effectiveness of protection strategies was obtained using the external method. Various game theory optimal criteria are used to select optimal defense strategies. First stage is to decision market and the attacker. Attacker strategies: threat 1, threat 2, threat 3, threat 4. You see some for the slide. You see some threats, and you see also strategy for enterprises. Strategy 1 is network micro segmentation, strategy 2, strategy 3, and strategy 4 regular staff training and so on. You see to the slide. Stage 2 is determination of the game's payment matrix. The elements of payment matrix were determined by expert evaluation. The expert will be interviewed in the operation enterprises like this: Kuehne Nagel, Sidr Schenker, LLC Zemler, and Zemler Ukraine. The winning of each player were estimated convention units points on a 20-point scale, and also value of 10 correspondents, high-level streets, and the value of corresponds to lowest level of the street. Also, we have some results, averaging experts, options, and concerning the table. And now we have some formula which shows the serial number of straits type, and also definitions with strategy S. This formula can be to see in this table too. You see some payments matrix of game points. It's strategies and stage 3, we application of optical criteria that determines the lower price of the game. This criteria will be minimum and maximum. Since the lower and upper prices of the game do not consider, we will look for solutions to game in mixed strategy. Let's introduce the notations XI, and we have different strategies. You see formula follow, and this formula can be show optimization model for the problem. And the next stage, we have some following distributions between strategies, and we decide the optimal. For example, 20% for network micro-segmentation, 29 for multiple authentications, 33 is systematic software and hardware upgrades, and on 18 is regular staff training. If we analyze the problem from the attacker's point of view, we get the following optimization model. It's problem 2. This is the other formulas, and these formulas show to be obtain the following distribution for attackers' resource between different types of streets. Not strategy, but streets. And we decide attacks on the network infrastructure is 25, attack on credential is 30, and social engineering is 45%. This our decision can be achieved when a player can improve his outcome by changing only his strategy if the other strategy remains. And we decide attacker enterprise, it's likely to combine attacks 25 probability on attacks on the network infrastructure, 30% probability at attack on a credential, and 45 through the social engineering. Defense enterprise, its optimal allocation of resources is follow 20% for network microsegmentations, 29 for multiple authentication, and 33 for systematic software and hardware updates, on 18% for regular staff training. This distribution minimizes the likelihood of an attacker's success and achieves optimal defense based on mixed strategy. At the same time, the enterprise will be able to achieve a positive value of the win estimate 0 to 38, which is significantly higher than the lower price of game and indicates the efficiencies of mixed strategy use. Conclusion. The study emphasizes the critical role of information technology in the development and efficiency of modern transport business structure. The use IT technology helps increase competitive efficiency and the operation business process. Given growth defense information technologies, models of transport level risk associated with cybersecurity is also increasing. The author proposed holistical approach to improving cybersecurity, which includes a number of technical organization and education missions. As one of the measures to reduce cyber threats, the author proposed to implement the zero trust. For the research, the directions will be aimed at expanding the use of descriptive methods for application of information technologies to the types of industrial enterprises in the contribution of mathematical models using game theory. Thank you very much for attention.
Thank you for providing of your results and for your report. And actually, we are waiting for the questions. Questions, please. Yeah, colleagues, we want to address the questions because it's really interesting and meaning results. Well, thank you again for your presentation, and actually it's pleasure to hear, and let's continue, and because we need to maintain our schedule, and we try again to provide the results of the previous speaker. Again,
Ми вже готові, якщо що, Артему Євгеновичу.
Добре. Тоді, якщо є готовність, the next speaker, the next topic is algorithms for controlling the models of a highly efficient hybrid mobile power complex. You have 10 minutes, please.
I can't share my presentation. Sorry. Do you see my presentation? It's all okay? Do you hear me?
Yes, we can hear you and can see everything. You can start.
Okay. Good afternoon, dear colleagues. The topic of my report is algorithms for controlling the models of a highly efficient hybrid mobile power complex. The global energy crisis has triggered the rapid development of alternative energy, and energy mobility has become a trendy hit today, allowing to solve the issue of the organizing a reliable power supply to various types of consumers in any area where there is a potential for energy from the sources used in a hybrid energy complex. Many researchers and inventors around the world are developing mobile power plants with renewable energy sources, as renewable mobile energy is now a solution to many issues in the energy sector. The mobility of energy, together with the use of the renewable energy sources, or RES, and the energy storage system, make it possible to quickly deploy the energy complex and supply consumers in the energy with the energy both in the everyday life, in emergency situation. A future of decentralized system in the complete intellectual of the management process. The introduction of mobile power plants and hybrid power complex today requires solving the issue of smart control of power flows and process of electricity generation and distribution directly in the mobile source consumer system. Thus, the development and use of algorithms for intelligent control of the operating modes of a hybrid mobile energy complex can significantly increase the efficiency of its operation. This is an important and urgent task for the energy sector. As a hybrid mobile power complex, the actors proposed a unit whose appearance is shown on this slide. The design features of the developed hybrid mobile complex are that includes 2 wind turbines and 2 photovoltaic units. Such a composition of the power complex significantly expands its capabilities and makes it highly efficient with increased reliability in the terms of energy supply to consumers. The presented design also includes a fairly powerful energy storage system based on rechargeable batteries, which can act as a backup power source. To develop algorithms for controlling a hybrid mobile power complex, the features of its operation were considered with a maximum consideration of requirements for it. Based on this information, the logic of controlling the mobile power complex in operating mode was formed, which is presented on this slide. Taking into account the postulations of control logic, control algorithm has been developed for these modes. Slide number 6 shows the selected values of the independent variables for the formation of the control algorithm in co-generation mode. Accordingly, control influence are formed in the form of logical functions. The logical of the hybrid mobile power complex functions depending on the change in dependent variables of presented in the form of a table. The next slide presents the result for the selected values of the independent variabilities of the logic of the hybrid mobile power complex function depending on their change for the split generation mode. To quantitatively analyze the future of the implementation of developed control algorithm for a hybrid mobile power complex, we have modeled its operation in the corresponding modes. To solve this problem, we considered the power grid to which the proposed hybrid mobile power complex was connected. The connection of the hybrid mobile power complex to the power grid can be varied, which ensures the maximum approximation of the generator source to the center of the electric load of consumers on the distribution network, and thus will reduce losses from the transportation of electricity energy, as well as unloading of power lines. A diagram one of these connection options is shown on this slide. The results of calculation of the characteristic study states modes of operation of the studied urban distribution power grid when powered by a hybrid model power complex with the use of the developed control algorithm are presented on the form of a table. The base mode of operation is one of when the generation from the hybrid mobile power complex is not used. The analysis of the results shows that the use of a hybrid mobile power complex with a developed structure when applying the developed control algorithm allows covering the load's needs in full. This confirms that the proposed algorithm for selection the operation modes of a hybrid mobile power complex ensures the regulation of the generated power in such a way as to achieve maximum efficiency under different needs of consumers of the power grid, as well as under changing climatic conditions of RES operation is developed installation. Thus, the intelligent control of operation modes of a hybrid mobile power system increase its energy efficiency and flexibility in supplying power to variable consumer loads. At the same time, climatic and technical factors are possibility of installation near each individual potential facility should be taken into account when implementing the developed energy complex. The article presents the following research results, like the first one. The developed hybrid mobile power complex based on alternative energy sources, which has designed features high environmental friendliness, energy efficiency, and durability of energy supply. The second, a structural diagram of a hybrid mobile power complex was developed to study its operation modes. The third one, algorithm for intelligent control of the power complex operation modes to improve energy efficiency. And the fourth, the analysis of the modes of the operation of the urban distribution power grid provided the high efficiency of using the developed algorithm for controlling the power generator parameters of a hybrid mobile power complex under actual climatic conditions and geographical features of the plant operation. Thank you for your attention.
Thank you. Actually, I need to ask for question for all of our guests, and also I want to provide the question to you. So questions, please. Well, let me to ask you the question. Well, in your project and this architecture provided, there is a combination of wind and solar sources of actually power generation, right? And
Yes.
there is a circuits or blocks for balancing of load when some sources can be connected to the customer, right? So
Yes, it's true.
there
Yes.
is a block that makes a decision, and there is a separate set of the accumulators. And when actually in this diagram, it's not completely clear why it's to perform such complicated switching. I mean, why we need to monitor the some source, for example, wind turbine or the solar panels, to start the consumption or to use a battery. So it's not clear why you are using this approach instead of the combining of all power and providing of that power to the customer. I mean, combining the battery, combining, I mean, the accumulator, combining the solar and solar panels and the wind blades.
Okay, I understand your question. The first, our idea of this complex is it's about not provide a high power generation. It's like to how we can say.
I think that the main idea is to maintain and support the customers.
Yes, yes, support the customers. Yes,
temporary problems with centralized electricity. It's completely clear. The question is completely directed to the circuit, how you switching the load between the sources, between the wind blade, between the solar panels and accumulators, because when the and you also using some load, additional load that that releases the electricity while there is no centralized load, right? So
yes,
there is some heater that actually turns the electricity from the wind to heating some load, right? So the question is, maybe it's to consider another way of combining of the sources, for example, with use of some AC with a constant current implementation. I mean, without the transforming with inverters after each source, but instead of that, it's possible to perform the accumulation directly in the DC, I mean direct current, and after that, the centralized power from the accumulators transfer to the customer without complicated switching, because it's this part is completely not clear in your investigation, while the rest is too relevant.
Okay, I understand your question. Our complex is very flexible. We can use different types of our sources, not only solar panel or wind turbines. I think in the future we can make this research, and that's the good idea for our future researches.
Okay, thank you. We are waiting for your next investigations, publications, and study because it's really important direction of the research. Thank you for your presentation and for your report. Thank you.
Thank you very much.
Well, we returning back to the another report, and I will try again to present it right now. Let me to try.
Good morning, dear listeners. Today I want to present a report on the topic analysis of technologies and ways of local interactions of smart home components with human. Speaker Samarchenko Vladislav Sergeyevich, scientific supervisor Перепелицын Artem Yevgenovich. In today's world, it is difficult to overestimate the relevance of home automations. Thanks to the development of Internet of Things, these technologies are increasingly integrated into everyday's life, increasing the comfort and safety of living spaces. An important component in Internet of Things technology systems is the interaction of the user with the system and devices with each other. The purpose of the work is to analyze the possibility of home automation using convenient options for user interactions with the device and Internet of Things technology. To achieve this goal, it is necessary to solve the problem of analyzing possible ways of local interaction with household systems and to propose a practical implementation of research results. First technology I analyzed is the Wi-Fi, which is a wireless data technology that allows you to connect devices to a network using access point. In the smart home, Wi-Fi is used to connect various devices that require high bandwidth, which is one of the main advantages of this technology. And among the disadvantages we can definitely highlight is a high power consumption. Bluetooth is a technology for exchanging data over short distances, often used to connect portable devices and accessories such as locks, speakers, or smart lamps. Its advantages are low power consumption and ease of integration into mobile devices. The biggest disadvantage is low data transfer rates and small effective range. Radio frequency data technology is used based on different frequency bands. It is effective for providing communications over long distances and has a high penetration capacity, but also has a low data transfer rate and is limited in encryption questions. Using VOC, visible light communication technology, which is a wireless data transmission technology that used visible light as a transmission medium, was also considered. In home automation systems, VOC can serve as an alternative to traditional wireless technologies such as Wi-Fi or Bluetooth, providing a number of unique capabilities. It has the advantages of high data rates, and it does not cause radio frequency interference, but data transmission is affected by ambient lighting, and this technology also depends on line of sight. ZigBee is a wireless communication standard optimized for high energy efficiency and supports a large number of devices on a single network. Its advantages is high energy efficiency and large amount of devices in networks, and disadvantages is the low data throughput, and it is sensitive to interference. Let's move to the methods of interactions. The first option considered was interaction using infrared radiation, which can be used to control household systems using motion sensors or remote controls. This technology is easy to implement and does not interfere with other data transmission technologies. The voice interaction method can be also used to control household systems by integrating voice control or voice assistance. However, the quality of audio channel can be limited due to a variety of factors such as distance, noise level, and the quality of audio equipment. And voice assistants are convenient and versatile method of interactions, but there are many disadvantages such as low noise resistance, dependence on the internet, and questions about the confidentiality of user data. Methods of interaction with users through gesture or symbol recognitions, such as QR codes within the home automation, are modern and innovative approaches. They allow users to perform contactless device management, which adds to the ease of use, but this approach is difficult to configure and is quite limited in the number of supported scenarios. In the course of the work, the Arduino Quick Prototyping Platform, which is a hardware development platform that is a popular choice for building home automation systems, was considered. It allows you to upload your own code to the boards and allows for even beginners to create smart systems to automate different processes. On this slide, you can see a table comparing the considered data transmission technologies and methods of interaction with the system. This comparison shows that for each scenario of using the system, you can find an appropriate technology. During the analysis, there were the analysis included the possibilities of quick prototyping, which have large number of available boards and modules with some ports for Wi-Fi, Bluetooth, infrared transmitters, relays, and others. The possibilities of user feedbacks are considered, namely indicators, sound modules, and displays. Thus, IoT Internet of Things solution allows you to control and manage household devices remotely, automate routine processes, and optimize energy consumption.
Well, I hope to provide the answers for the question, and I will be happy to answer for the questions. Actually, the student is unable to be here because of the problems of connections, but I will be happy to provide the clear information about the performed analysis, and we are waiting for questions. Questions, please. Well, if there is no questions, we are moving to the last presentation in our timetable. It's detecting objects in photos and videos obtained by aerial reconnaissance from UAVs. One second.